Shall we give same reason why the liquid will rise? So again, the idea is same here. There's a point 1, there's a point 2, there's a point 3. So we are very sure is what pressure at 1, 3 equal to P naught. So pressure at 2 less than P3. So therefore, so what happened to liquid? Liquid will rush. So what the liquid will do? It will flow like this. Now, what are these arrows? Flow of liquid. At least looking at arrow, you must understand. So there's a flow of liquid. So P2 less than P3. So therefore, P1 greater than P2. So the liquid will rush into the capillary tube. It will rise. And how long the liquid will flow? Till the pressure at 1 becomes equal to pressure at 2, that one. So now what will happen here? P1 equal to P2 equal to P5 equal to P naught. I think this already we have every problem I repeated. Okay, now let's see that one. Now, is there any heat released or absorbed in the process in capillary rise? Who will drag this? Please, all of you look at, I'm discussing something. Here, force due to suffocation should come. Why force due to suffocation like this? Meniscus should be of like this here. This is shape. Fine. So how the force due to suffocation should act here? Should act tangentially. So shall I put F dash? And what is F dash? Force due to suffocation. A component of force will act vertically. So that force due to suffocation will drag the liquid column vertically up. How long? How long? So like this it will drag. And what will happen to the liquid column? Why do it will come to rest here? Because of viscous drag forces, because there'll be viscosity. There'll be viscous drag will be the acting between the layers of the liquid. Because of that, what will happen? There'll be heat will be generated. Find this one. So work done by surface tension. Surface tension does work. A part of it is used to rise the internal energy, to rise the gravitational. Remaining is what? Converted into heat to overcome the heat. So finally, when the liquid rises to IH, no, so we get like this. F dash. We'll assume angle of contact to be 0. So then it become vertically up. Now the what this force due to suffocation, it is pulling the meniscus from to IH. So what is work done by surface tension? Work done. Now there's a very important theoretical idea. Work done by surface tension force in pulling the meniscus to IH. What shall I write here? St into 2 pi r. Let r be the radius of capillary tube into what? H. What is St into 2 pi r? Is the force due to surface tension. Because where the force due to surface tension will act at the meniscus, no? Theta equals 0, so that force will be acting vertically up. I think by this time you know how to calculate force due to surface tension. St into 2 pi r. To what height it has undergone displacement? This much here. Okay, now we know what is H is equal to. We know. Anybody? What shall I write? 2st by rho gr. The liquid will rise to this much of height. Substitute that one here. 2 pi st r h is 2st by rho gr. R get cancelled. So 2 pi st square. Now 4 pi st square by rho g. There's a work done by the suffocation in rising the liquid to height h, pulling the meniscus to height h, or rising the liquid column. There's a liquid column. No. What is the increase in gravitational potential, G? Increase in gravitational potential, G, of liquid column. Delta U are writing. Anybody? What should be the increase in gravity? You know center of mass. So what is the mass of the liquid? Rho pi r square h. This is a mass, no? mgh, what we write it, no? Gravitational potential G. Potential G possessed by a body by virtue of its height. What is the mass? Mass of the liquid column? Rho pi r square. But sir, you are showing meniscus, but you are writing cylindrical volume. Volume of water in the meniscus is negligible because volume of the liquid in the meniscus will be negligible compared to volume of liquid in the capillary tube. Okay, this is the mass into gravity. What shall I write height here? H or h by 2? Anybody? Because center of mass got over. We know center of mass idea. H by 2. Okay, good. Yeah. Height of the center of mass, it should be. Fine. Huh? Okay, all of you able to think? Okay, nice. Yeah. Now we'll go for rho pi r square g h square by 2. What is h? Again, let me substitute this formula. 2st by rho g r whole square. Okay, if I do everything, rho g1, everything get cancelled. So this will become 2 pi ft square by rho g. Look at this. How much sufficiency did work? 4 pi ft square by rho g. What is the rising gravitational potential G? 2 pi ft square by rho g. Where do remaining of gone converted into heat? Why do the heat? Because what is the water? What is the water usually? What is the water? Water, you take any liquid will have a viscosity. Viscosity is a viscous force is a non-conservative force. So when the water is moving, so when the water is rushing like this, so when it is rising up, there will be a viscous drag between the layers of water. To overcome that, what kind of energy is needed? We will provide a part of work done by sufficiency. So remaining of will be converted as heat and it will be released as heat. Tomorrow I'll start viscous chapter. Okay, on the Friday, what happened? I'll take one more problem related to this. Now, time being, what happened? Where do that difference in energy gone? It is used to overcome the viscous drag between the layers of water when the liquid is rising inside the capillary tube and convert into heat. So shall I say heat is released? So in capillary rise, heat will be released or absorbed. Heat will be released. So therefore, so what shall we write here? No, I'll bring everything. Okay, this is this is a very important theoretical idea. It's not a numerical. It's not a numerical. Please don't take it like a numerical. So there's a basic idea of the capillary. Plus heat generated. Where the heat is generated? Heat generated in the liquid, not in capillary glass tube, in the liquid only. Heat generated in the rising liquid, or better ascended liquid, you write it. Rising liquid. So how much that heat generated? So we know work done by sufficiency delta U plus H. So what is H is equal to? WST minus delta U. I think this should be equal to how much? 2 pi ft square by rho g. So in a capillary rise, heat will be, energy will be released or absorbed. Energy will be released. Shall we put a conclusion? Therefore, very good theoretical things, so they will trouble you. Be careful. Therefore, in capillary rise, energy is released. Now, sir, like a here, what is the type of liquid we are bringing? Okay, there's about the thing. Now, if the liquid wets the solid, then only it will rise, no? If the liquid will not wet the solid, then if I bring a capillary tube, I'll immerse in a mercury. Mercury, will it wet? No, it will not wet. So what will happen to the mercury now? Mercury will not rise. In fact, it will fall. There is some general idea.